Hey everyone! Welcome back to 3D Print Sensei. I'm excited to kick off a brand new series all about transforming your sketches into awesome 3D prints and functional objects. Over the next few videos, we'll be diving deep into the process, from concept to creation. First up, we're tackling a real-world problem with a creative solution. Let's say you just got a sweet new bike mirror, but for some reason, it doesn't quite fit your handlebars. Sound familiar? In this series, we'll show you how to create a custom 3D printed adapter that bridges the gap and gets you back on the road safely, with a touch of personal flair. The problem. Let's face it, handlebars come in all shapes and sizes, while most bike mirrors stick to a standard size. This mismatch can lead to a wobbly mirror, compromising safety and style. It is very frustrating, but you're not alone. This first project tackles that exact problem with a creative twist. We'll be using the power of 3D printing to design and build a custom adapter, turning that incompatible mirror into a perfect fit. Stay tuned to see this problem turn into a printed project. Taking measurement. Before we jump into the exciting world of 3D design, let's tackle the first crucial step: measurements. We need the exact dimensions, so grab a ruler or some calipers. Digital ones offer great precision. We'll need the diameter of your handlebars at the mounting point, the diameter of the mounting hole on your mirror, and the dimensions of the connector. Don't forget to jot down any unique shapes or features on either piece, as these details might influence our design. With these measurements in hand, we'll be ready to create a 3D model that seamlessly connects your mirror to your handlebars. Onshape is a parametric CAD, computer-aided design program. This means you define your design using parameters, like the handlebar diameter, instead of manipulating individual points in 3D space. Why use Onshape? This focus on precise measurements and engineering principles might be more suitable. This makes it easier to make changes later on, and it's free to use. All right, folks, it's time to unleash your inner designer and create a solution with Onshape. Here's a step-by-step guide. Step 1. Fire up Onshape and create a new document. This is your blank canvas where the magic happens. Step 2. Import your measurements. We finally get to use those meticulous measurements you took. However, before we jump in, Onshape needs a little preparation. Think of Onshape as a drafting board, but in 3D. To define your design, we need a flat surface to work on, kind of like a sheet of paper. These flat surfaces in Onshape are called planes. We'll need to create a sketch on one of these planes to begin. The good news is, Onshape allows you to directly set the dimensions of your design elements within the sketch. This makes modifications super easy later on, which is why we'll be using parameters. Step 3. Set up the parameters. Instead of manually creating specific shapes with exact sizes, we'll define variables called parameters. These parameters will hold the actual measurement values you took, like for the handlebar connector diameter and the hole diameter. Then, when you use these parameters within your sketch, Onshape automatically adjusts the size based on the values you entered. This way, if you want the connector to be slightly wider, you simply change the value in the #width parameter, and Onshape updates the entire model for you. No need to painstakingly redraw everything. So, let's get those parameters set up and ready to use. Step 4. Building the connector. Let's get to work on the core component of your adapter, the connector. Here's a breakdown of the steps. Base for connector. Create a new sketch on the top plane and rename it to bottom or something unique to your design. Use the circle tool to draw a circle representing the base that fit into the adapter of your handlebars. Remember those diameter measurements? This is where they come into. Once you're happy with the circle, use the Extrude tool and select the upper plane as the ending point. This will transform the circle into a solid cylinder, forming the base of the connector, creating the hole. Flip to the bottom face of the cylinder, the one we just extruded. Create a new sketch on this face using the Inscribed Polygon tool. This tool allows you to draw a polygon within a circle, defining the shape of the hole. The number of sides you choose will determine the shape, 6 for a hexagon. This will define the shape of the hole in the base so the screw will fit. Once you have the desired polygon shape, use the Extrude tool again. This will remove the material within the polygon, creating a clean hole for the screw to pass through. Don't forget to rename the sketch for clarity. The middle of the connector. Use the trusty circle tool once more to draw a circle representing the middle section of the connector. This circle will connect the top and bottom parts. Now comes the magic, the Loft tool. This powerful tool allows you to create a smooth transition between two or more profiles. In our case, the top and bottom circles. Select the two relevant sketches and define the direction of the loft. Onshape will generate a smooth solid form connecting your base and middle section. The top of the connector. Create another sketch on a suitable plane. Use the circle tool once more to draw the outer circle representing the top of the connector. Draw another circle inside the first one, creating a donut-like shape. This inner circle will define the opening. Once you have the desired shape, use the Extrude tool to create a solid form from the sketch. Choose the appropriate direction to ensure it connects seamlessly with the middle section we created earlier. Flexibility is key. You can add parameters later. Learning about them while building the model can be a good way to experiment. Here's how to incorporate parameters for easier future adjustments. Identify the dimensions you want to control, for example, the width of the connector. Head over to the Parameters section, create separate parameters for each dimension, and assign the actual measurement values you took earlier. The magic happens with a symbol, the hashtag. By using the hashtag symbol with the name of the parameter, example hashtag width, you can reference it within your sketch dimensions. So, go back to your section representing the connector base. Replace the fixed size you entered earlier with a reference to the corresponding parameter. This ensures a perfect fit based on your actual measurement. This gives you ultimate flexibility in refining your design. Building the fin to ensure snug fit. The fin is a crucial element for a secure fit. Create a new sketch on a suitable plane. Consider the placement of the fin and choose a plane that aligns with your design goals. Use the trusty rectangle tool to define the basic shape of the fin. Now, let's define the exact size of the fin. Add dimensions for both the height and width of the circle. But instead of fixed values, this time, assign a parameter for each dimension. This allows you to easily adjust them later if needed. Use the Extrude tool to create a solid form from the sketch. Set the depth of the extrusion to match your desired fin size. To ensure the fin sits correctly, you might need to adjust the offset value in the extrude settings. This essentially moves the starting point of the extrusion left or right from the chosen plane. Finally, use the chamfer and fillet tools to refine the edges and corners of the fins for a smoother and more finished look. Adding multiple fins. The beauty of 3D printing is the ability to customize for functionality. In this case, let's add multiple fins to your adapter for an extra secure fit. Onshape offers a fantastic tool called Circular Pattern that allows you to easily replicate features around a central axis. This is perfect for creating our multiple fins. We need to tell Onshape which element to pattern, to copy, and around what axis it should rotate. We want the fins to completely encircle the base, so set the angle to 360 degrees. This tells Onshape to rotate the copied fin a full circle. For the number of fins, set the instance count to 4 and equal spacing. This ensures each fin is evenly distributed around the base. Onshape automatically create 4 copies of your fin, perfectly spaced around the bottom plane of your connector. You've successfully added multiple fins for a secure and stable fit. Remember to give your pattern a descriptive name for better organization. Refine and finalize. We've conquered the design stage. Now, let's bring your creation to life. Once you're happy, Onshape lets you export your design in various 3D printing formats, like STL or OBJ. This is a 3D print format and can now be read by your 3D printer. Upload your file and choose your desired printing material. Remember, consider strength and weather resistance for a bike part, so I use PETG. Open Bamboo Studio. This software slices your 3D model into thin layers, essentially providing instructions for your 3D printer. Import your exported model from Onshape into Bamboo Studio. Once you're satisfied with your settings, it's time to send the sliced model to your 3D printer. When you're ready, confirm the print job and watch your custom connector come to life. Don't worry if your design isn't perfect on the first try. It's easy to make adjustments in Onshape. This is exactly what I had to deal with to achieve a perfect fit. Whether is that those meticulous measurements is slightly off, or it's just finer details that need adjustment. As you build, you might discover a better way to achieve a specific function. You can adjust the parameters, dimensions, or even the sketch itself to achieve the desired change. This benefit allows you to iterate and refine your design until it's perfect. Lessons learned. A quick test print is your best friend. This allows you to compare the printed dimensions with your original design. Aim for a difference of around 0.2 mm, with 0.1 mm being ideal. Calibrating your printer. Nozzle height. This plays a crucial role. Going too low can lead to printing issues, so keep it above 0.06 mm. X, Y, and Z settings. Fine-tuning these settings can significantly improve overall dimensional accuracy. Infill refers to the hidden world inside your 3D print. It's like the skeleton that gives your creation its strength and weight. More infill, more strength. But this also uses more filament and increases printing time. For my connector, I had to increase the infill. Finding the balance. A moderate infill, around 50%, should be a good starting point. Remember, you can always experiment with infill settings later to find the perfect balance between strength and efficiency for your specific needs. PLA does not like heat or constant strain, and because it's for a bike part, I decided to print it in PETG, which is better strength and weather resistance. Voila! Your custom-made solution should have your mirror sitting proudly and safely on your handlebars. Now, the moment of truth. It's time to test the fix mirror and hit the road with confidence. The conclusion. That's it for this project. We've conquered measurements, unleashed your inner designer, and have seen this creation come to life. If you have any questions about design or another bike part that is begging for a 3D printed solution, or you are interested in an in-depth Onshape beginner video, leave a comment below and I can make another video. Stay tuned for the next video in this series. Please like this video, hit that subscribe button, and ring the bell. This is 3D Print Sensei. Thank you for watching.